Alright, in this video we're going to simplify another expression involving rational exponents. This one happens to have a quotient of powers going on and more than one variable. So as we simplify, your answer should contain only positive exponents with no rational, meaning fractional, exponents in the denominator. Let's begin. First, I'll take a look at the denominator and take it a piece at a time. So m to the 1/2, n to the 3/2 gets raised to the 1/3 power. Because these have different bases, m and n are different, I can't add these exponents together. What I will do is I will take this 1/3 and apply it to both parts of this. Now, when I apply it to both factors of this product, m to the 1/2 raised to the 1/3, that means I'm going to multiply those powers together. Same thing with the 3/2 and the 1/3. If I multiply here, again, writing that out just so we see what's going on here, 1/2 times 1/3, top times top, bottom times bottom, we're going to get 1/6. And when I take 3/2 times 1/3, I'll do that in a different color, we're going to take top times top, bottom times bottom. In this case, I could probably cancel the 3's right away. 3 over 3 is 1, so that's going to equal 1/2. So what I've got so far with this expression on the left is I've got m to the 1/6, n to the 1/2. I'm going to do the same thing now with this expression. We'll take the 1/2 and apply it to both parts here. Again, these are different bases. I can't add their exponents together. Multiplying exponents, I take 5/3 times 1/2. That's going to be the same thing for each, so I'll only have to do this once. 5 times 1 is 5. 3 times 2 is 6. So m to the 5/6 and n to the 5/6. So I was multiplying these together when I started. I'm still multiplying, so I can just kind of write them all next to each other like so. Because I am multiplying powers together, now I notice that I have the same base here and here, which means I can add these exponents together. 1/6 plus 5/6, well, that's 6/6, which is 1. That's pretty convenient. So this is going to equal, slide it over here, m to the 1st. How nice. The n's, I see an n here and here, same base. I can add the exponents together. 1/2 plus 5/6, I'll jot that down so we see what we're doing here. 1/2 is the same as 3/6. I'll multiply top and bottom by 3 over 3. It turns into 3/6. 3/6 plus 5/6 is going to be 8/6. So I have n to the 8/6, like so. That's an exponent, tough to tell. Now, I still have this m to the 3/2 and n to the 1/2 in my numerator. So now checking out what we would do here. Looking at the m's first. M to the 3/2 over m to the 1st. Remember, when I have the quotient of powers, I would subtract exponents. This is like m to the 1st. 3/2 minus 1. Well, 1 is the same as 2/2. So 3/2 minus 1, or 2/2, is going to equal 1/2. So m to the 1/2, that'll be in my numerator. Then I've got n to the 1/2 over n to the 8/6. What we're going to do is we're going to subtract these exponents too. So 8/6, this I should change into 3/6. Make that 3/6 instead of 1/2. 3/6 minus 8/6 is going to be negative 5/6. It's kind of a goofy thing to have. So we got n to the negative 5/6. Now, normally we don't like negative exponents, but we were told to have only positive exponents, with no rational exponents in the denominator. So we've got this, there's no denominator anymore. We have just a numerator, and it's these two expressions. But I've got this negative exponent, and I was supposed to only have positive exponents. So here's what's going to happen. If I put n to the 5/6 back in the denominator, we're going to draw this way over here. We had m to the 1/2 over n to the 5/6. In order to have only positive exponents but not have fractional exponents in the denominator, I want to have a whole number exponent. So I think to myself, what would I have to multiply by? I'm going to multiply by some power of n. N to which power? What I want is I want to be able to say that in my denominator I have n to the 1st, and that's it. Well, I have 5/6 here. Whatever exponent I decide to put right here is going to be added to that exponent. So think to yourself, what do we add to 5/6 to get 1, or 6/6? Well, that would be 1/6. So n to the 1/6 times n to the 5/6 is going to equal n to the 6/6 or n to the first. I can do that as long as I multiply the top and the bottom by the same thing. So I'll put n to the 1/6 right here in the numerator. And multiply these, well, let me just write them next to each other because they have different bases. So m to the 1/2 times n to the 1/6 over n to the first. Only positive exponents, no fractional exponents in the denominator. This is a final answer. Even though n shows up in two different places, this is okay because it abides by the rules that we were given here. Positive exponents and no fractional rational exponents in the denominator. That's good.